Yeah, so my name is David Mitlyng. I'm the CEO of Xairos. A little bit different from other groups here. We offer quantum time transfer that we believe is very important for network security by augmenting timing from GPS. Now, when people think of GPS, they think of this, your location app on your phone, but the GPS's real value is the clock for the world. All networks, financial transactions, and power grids rely on a timing signal from GPS. And if when GPS ever went offline, we would lose all communications and power within a couple of days. This is a huge problem, it's very well known, that needs to be solved. And that we think quantum time transfer gets us there. Now, when you think of security, you look at QKD. QKD provides the highest level of security, but GPS, the timing comes from a weak RF signal that is trivially easy to jam and spoof. It pretty much has zero security element to it. So the value proposition of quantum time transfer is it provides integrity of the signal, a trusted, authenticated timing source, and availability by making that link very difficult to jam. It's set up similar to entanglement type QKD, but in this case, in entanglement type QKD, you're sending entangled photons between two parties, Alice and Bob, and it creates a random string of bits that is used to create a set of encryption keys. But in quantum time transfer, we want to synchronize Bob's clock to Alice's master clock. And if the distance is the same between, distance is known between Alice and Bob and static, then we can use that exact same setup for quantum time transfer. Now, in cases where the distance isn't known or it's dynamic, we use two-way time transfer. That way we can remove distance as an unknown variable. It doubles the hardware, but it also adds a bit more precision to the accuracy of the system. Now, quantum time transfer works fundamentally the same way that RF and optical time transfer works right now. Alice creates a signal, it's an RF signal where the phase changes create a pseudo-random code that is tied to her clock. Bob measures that. He has the same pseudo-random code that is tied to his clock. They do a correlation, and that correlation peak tells you the offset between Alice and Bob's clock. So quantum time transfer works fundamentally the same way, except you're using the discrete clicks that come with the photons hitting the detector. But in the case of optical RF time transfer, Eve also knows that same pseudo-random code, so can transmit that and maybe convince Bob that it's Alice, the source. But the creation of entangled photons in quantum time transfer are fundamentally random. So Eve can't know that pattern and can't pretend it's Alice. The other value of the security element is the fact that Eve can't measure Alice's signal and retransmit it the same way you can with the RF signal due to the no cloning theorem, and so can't create a delay and spoof Bob. Now, we've already built this in a proof of concept, but now we're looking at this as an architecture that can augment timing from GPS. So you can start with a satellite, for example, that synchronizes to a master ground station clock, say from JILA or U.S. Naval Observatory. That then becomes the master clock over a large geographic area that provides time distribution over a network from the satellite and through fiber. And then this becomes a nice way to augment GPS, because then you can provide that last mile RF signal to your consumer device through cell, position and timing signal through a cell or Wi-Fi signals. And, the value of this is particularly for urban canyons and large cities indoors. That's a much stronger signal. It's a much more resilient backbone that can't be spoofed or jammed. So as a company, we've this system protocol was invented by our co-founder in 2018 and written in a paper. It was patented. We formed the company around that technology in 2019. Got a number of U.S. government contracts. But the papers were out there, and other groups have replicated some of the original work that we've done, particularly in China. So Chinese researchers have, kind of developed this, and definitely, as it's probably a lot of people on the call know, or this webinar know, China is very serious about having quantum secure networks. But most of these groups have focused on one-way quantum time transfer over static links, over fiber. We built our proof of concept to demonstrate two-way time transfer and advanced simulation to look at this for dynamic links. So as a company, we're now kind of at that turning point where we have some commercial opportunity to install our system in networks for network providers that want to add that level of security. With this webinar, we want to have partnerships and investment. We're a small team, so we want to be able to address those opportunities. So that's what we're doing. Thank you.